Okay, so dealing with probability, we're going to be looking at the probability of mutually exclusive events and dependent events. So real simply, I think it's easier, more than a formula, is just to think through each problem. So this first problem, a six-sided number cube with faces numbered 1 through 6 is rolled. What's the probability that a 2, 4, or 6 will be rolled? Well, going back to our formula, the probability equals favorable outcomes over total outcomes. So if we think about that, what's the favorable outcome? When we roll a dice, we have a total of 6 different options, right? And so the favorable ones here are 2, 4, 6, which is 3 of the options. So therefore, if you simplify that, the probability would be 1/2 would be the answer to this one. If it would have been 1 out of 6, it would just be one of them. You could just add each probability to get a total of 3 out of 6, which is 1/2. Same thing. Okay, let's look at example number 2. So in this example, a bag contains 7 red blocks, 19 yellow blocks, and 10 green blocks. Jordan picks one block from the bag at random, records its color, and then without replacing it, I'm going to underline that, picks a second block. What's the probability that he will pick a red block first and a green block second? So I think the first thing that we want to do is add up the total number of blocks. So we have 7 red blocks. So 7 plus 19 plus 10 equals 36. So again, we're going to do the favorability of over total. So the favorable over total. So we have basically 2 problems here. So the first one is, what's the probability that he will pick a red block first? So Jordan picks one block at random, so a red block, 7 over 36. Okay, that's the probability that he will get a red block first. And now what's the probability he will get a green block second? Now remember that he did this without replacing it. So when he got that first red block, he doesn't replace it, so that's going to be 35 now blocks in the bag. What's the probability that he'll get a green block? Well, there's 10 of those. So you multiply those answers together to get, let's get our calculator out. Obviously this is going to be 70 over, let's find our calculator. It's not going to let me move it, but 36 times 35 equals 1,200 and 60. Now, if we're to simplify that, I think we would get 70 goes into both of those. So if we divide 70 divided by 70 equals 1, and 1,260 divided by 70 gives you 18. Now, it's either a 1, that's our answer, it's either a 1 out of 18 chance, or if we're going to get the percentage, 1 divided by 18 is 5.55. That's giving the wrong statistic, but it should give 0.05, or that's repeating. So, or about a 5.5% chance. So just to recap, when doing a problem like this, you do the first probability times the second probability. And that is how you do the probability of mutually exclusive events and dependent events. This would be an example of a mutually exclusive event, and this would be an example of a dependent event.